Welcome to this explainer. Today, we're stepping right into the high-stakes world of concrete construction. If you've ever walked past a massive building site, you've definitely seen the temporary molds holding all that wet concrete in place. That's the formwork. But have you ever stopped to wonder exactly how engineers know when it's actually safe to take those molds away? It's a highly calculated science, and getting it wrong? Well, that can have absolutely disastrous consequences.
Just look at the sheer scale of the concrete work here. Stripping formwork too early can literally lead to catastrophic structural failure, putting lives and the entire project at risk. But on the flip side, waiting too long ties up expensive materials, wrecks your schedule, and wastes a huge amount of money. So how do we find that perfect balance? And more importantly, what is the actual reasoning behind the standards that dictate this timeline? Today, we're going to completely unpack the engineering logic behind the Indian Standard Code IS 4562-2000, specifically looking at how it assigns stripping times for different members of a frame structure, while bringing in some core insights from MS Shetty's renowned textbook, Concrete Technology.
Here's our roadmap for cracking the code today. First, we'll cover the golden rule of strength, then vertical versus horizontal members. After that, the impact of span length, and finally, cements and temperature.
Section 1. The Golden Rule of Strength. Let's get right into the foundational physical principle that governs exactly when every single piece of formwork can safely come off.
The absolute crux of it comes down to this exact text from IS 456-2000, specifically Clause 11.3. It clearly states that we need the concrete strength to be at least double the immediate stress it's going to endure the very second that formwork comes off. Professor MS Shetty highlights this rule extensively because, honestly, it's the bedrock of construction safety. Notice, we aren't waiting for the concrete to hit its absolute maximum strength. We're just waiting for a very specific safe threshold.
So to really understand that threshold, we have to look at what we call stripping stress. When you pull that formwork away, boom, the concrete suddenly has to support its own immense deadweight, plus the live load of all the construction workers, tools, and maybe materials stored on top of it. As MS Shetty points out, we don't need to sit around waiting for the full 28-day characteristic design strength. We just need a factor of safety of 2 against a real-world immediate stress that concrete is facing on that exact day.
Section 2. Vertical versus horizontal members. Now let's apply this golden rule to the actual physical shape of the building. What's really fascinating here is the sheer contrast in structural mechanics. Why does IS 456-2000 treat a column completely differently than a floor slab? Well, it all comes down to gravity. Vertical members, like your columns and walls, primarily suffer compressive stress. They're just standing there, transferring that load straight down. But horizontal members, like the soffits, which is just the underside of your slabs and beams, they suffer bending stress. Gravity is literally trying to snap them in half under their own weight. Because columns, walls, and the sides of beams primarily deal with this straightforward compressive self-weight without that added danger of bending, they just don't need a massive amount of early strength to hold themselves up. Because of this, IS 456-2000 says their forms can safely come off in just 16 to 24 hours. Basically, once the concrete is hardened enough that the surface won't tear away when you rip off the plywood or steel, it can stand entirely on its own.
But horizontal slabs and beams, they face gravity head-on. The code dictates a strict minimum of 3 days before you can remove the soffit formwork for slabs and 7 days for the underside of beams. You might be wondering, why do beams take longer than slabs? It's because beams carry the load of the slabs. They are the primary load-bearing arteries of the entire floor system, and they take on some serious concentrated bending moments. And don't miss that crucial asterisk right at the bottom. Props must be refixed immediately. Even though the concrete is strong enough to let you strip the main surface boards, it is absolutely not strong enough to carry its full weight unassisted yet. So we have to swap the solid formwork for temporary structural props.
All right, Section 3, the impact of span length. Let's see what happens to the math when we introduce the massive scale of different spans into the equation.
So remember those props we just carefully shoved back under the concrete? When can we finally get rid of them? The code maps this out perfectly. A longer span means exponentially higher bending moments and a much heavier dead load. For a slab spanning up to 4.5 meters, those props stay for 7 days. But stretch that slab larger than 4.5 meters and that requirement doubles to 14 days. And for heavy beams and arches spanning over 6 meters, the required prop time gets pushed all the way out to 21 days. The code is literally scaling the stripping time directly with the mathematical increase in bending stress.
Put it all together, and you get this beautifully orchestrated timeline of a frame structure. Imagine standing on a job site watching this sequence unfold.
From hour 16 to day 21, the timeline is mapped flawlessly to the hierarchy of structural stress. We strip columns first because they only face compression, then the slab soffits, then beam soffits, and we deliberately leave the primary supporting props under the longest spans for almost a full month. It's an incredibly deliberate sequence designed around the safe, progressive loading of the concrete frame.
Finally, Section 4, Cements and Temperature. Now we have to look at the environmental variables that can force us to throw these standard code timelines completely out the window.
Because, as we know, concrete doesn't cure in a vacuum. All the exact days and hours we've pulled from IS 456-2000 rely on a very specific, idealized set of baseline assumptions. But what happens when you pour a slab in the dead of winter? Or what if your mix design calls for a special, slow-curing cement? MS Shetty's textbook emphasizes a crucial concept here. Concrete strength is a function of maturity, which is essentially a product of both time and temperature.
The fine print in the IS code is super explicit. That 16-hour to 21-day timeline, it assumes the ambient temperature never drops below 15 degrees Celsius, it assumes you're using standard ordinary Portland cement, and it assumes you are actually curing the concrete properly. If temperatures drop below 15 degrees, the chemical hydration of the cement slows to a crawl. Same goes if you use Portland, pozzolana, or slag cements, the early strength gain just isn't there. When that happens, the code mandates that you must modify and extend those stripping times. You can't just blindly follow the calendar on the wall. You have to calculate the actual strength development happening under those specific field conditions.
So, whether you're building a standard residential high-rise or a massive infrastructure project, the underlying principles are exactly the same. To sum up the whole shebang, stripping formwork is never just about looking at a calendar. It's this incredibly careful, calculated dance between how fast the concrete develops strength and the structural stress it's about to take on. Every single number you read in IS 456-2000 exists for a very specific mechanical reason, perfectly balancing the pure compression of vertical columns against the severe bending moments of long-span beams.
I really want to leave you with this final thought. The next time you're checking IS 456-2000, remember the actual structural mechanics that are dictating those numbers. Formwork removal is literally the very first time a structure feels the harsh reality of its own weight. So, are you absolutely certain you've respected the twice the stress rule? And is your concrete truly ready to carry the load?